In this lecture, I will be presenting the firewall design and management. In the earlier lecture, I have presented the firewall basics, in which we have seen the software and hardware-based firewalls. Under the software-based firewalls, we have seen stateless and stateful firewalls. We'll see in this lecture the designing of the firewall configuration. So firewalls can be deployed in several ways. Especially the firewalls has to be deployed at the entry level of the computer networks or the networks. So here firewalls can be deployed in several ways. One is as part of the screening router, we can place it, or a dual home host, like that also we can place, screen host, and screened subnet DMZ, multiple DMZs, multiple firewalls, reverse firewall. So these are the categories in which the firewalls can be deployed. In this lecture, I will be explaining one by one that where the firewall settings can be placed. So in the previous lecture, we have seen the software-based firewalls in which packet stateful and stateless firewalls. And along with that, we have also seen firewall component position. That means where you are supposed to place the firewall. So this lecture totally deals with the configuring of the firewall at multiple locations or at various locations in the network. So in order to achieve the defense in depth, concept. So screening routers. Screening router means determining whether to allow or deny packets based on their source and destination IP addresses or other information in their headers. Does not stop many attacks. So the screening routers will not stop many attacks. It only will say that okay, whether to allow this packet or not. Especially those that the spoofed or manipulated IP addresses information cannot be filtered by this screening routers, should be combined with the firewall or proxy servers for getting more protection. That means the screening routers as it is cannot be used. So here internet or untrusted network from which communication is coming into the routers. So here it is a screening router. Router at network perimeter processes the traffic based upon the rules based and will come into the internal network. So the advantage of this is very simple, but it cannot stop the traffic which is coming from these spoofed IP addresses. A dual homed host computer that has been configured with more than one network interface. Only firewall can forward packets from one interface to another. Firewall is placed between the network and the internet, provides limited security because firewall depends on the same computer used for day-to-day communication. Host services as a single point of entry to the organization. So the attackers only have to break through one layer of protection to capture to hack the internal network. So what is the dual homed host? So here in case of screening router, the external communication is connected to one port, and from there one of the port is connected to the switch and switch to the local area network. Like that it will be connected. But whenever you place a computer here, usually the computer will be having one network interface card. But you are supposed to attach two network interface cards at least. So one is for the incoming connection and one is for the connection to the internal network. That is what they call a dual homed host. So dual homed host will be having more than one network interface cards. For example, like this, a dual homed host example is like this. An internet which is coming from outside, and here is the firewall with the dual homed host. Firewall software controls all the packets handled through the host information. And this dual homed host will be having two network interface cards. One is external network interface cards and the internal network interface card. External network interface card totally connecting with the public network. So you look at here the IP address mentioned here 201.200.119.1, which is the public IP address. Where in case of here internal network interface, which is the local IP address. or we can say private IP address. So this private IP address will be connected to the internal network, where here the host that is mentioned here. Look at here is like a CPU cabinet. Okay, this is a host for which you are supposed to attach two network interface cards. So computer hosting firewall, all traffic and packet handling capabilities are disabled here. And based upon the type of traffic to be allowed, the policy rules will be set so that from the external network interface to internal network interface, the traffic will flow. This is what is called dual homed hosts. In the screened host, similar to a dual homed host, except router is added between the host and the internet to carry out the IP packet filtering. Combines a dual homed host and a screening router. Might choose this step for perimeter security on corporate networks. Can function as an application gateway or a proxy server whenever you attach this form of arrangement in the network perimeter or the perimeter security. Previously, whatever we are using is with a simple router, and the next setup is also a very simple thing, that is a host will be placed. Right? But while coming to the next arrangement, a router followed by the dual homed host. So this is a little bit complex one. Look at here. Traffic coming from the outside world. This is the packet filtering or packet filtering router screen host here. That means most of the unknown, or sorry, most of the known traffic will be allowed into the computer or into the network. That means at this level, most of the unknown traffic can be eliminated. Okay, unknown traffic can be eliminated. So known traffic can be allowed into this network. But here in the dual homed host, because since we are receiving the related traffic, and based upon the security policy that we set here, we can filter from the known traffic. We can make a pure filtering of the original traffic that is supposed to be accessed with the internal network. So that means we have considered packet filtering as a one filter, and dual home also was one filter in the previous two cases. But now, because of the combination of these two, so more fine-grained traffic, which is a genuine traffic, that can be allowed into the internal network. Screen subnet DMZs, that is demilitarized control zones. DMZ, subnet of publicly accessible servers placed outside of the internal LAN. Common solution is to make servers a subnet of the firewall. The firewall that protects the DMZ is connected to the internet and the internal network, called as a three-pronged firewall. Might choose this setup when you need to provide service to the public. So here you look at to make more secure system. So internal internet or untrusted network, the communication is coming into the pre-homed host. Previously, it is dual homed host, where you will be having an external interface and internal interface. Now, what will happen with this pre-homed host, this particular host? One more line is added here, which is called screened subnetted demilitarized zone. We know that in DMZ, we will always place the publicly accessible servers in the DMZ. Now, from here one external interface and here one internal interface, and to connect this to this, one interface is required. That means this connection, that means this host should have at least three network interfaces. So whenever this host has three network interfaces, that means three LAN cards must be provided to this. So one LAN card is connected to the external interface, one is to the internal, one is to the screened subnet DMZ. So that means this is the one which is where you are going to place this what you call a hardware. We can say the network interface or LAN card is a hardware. For example, you want to connect LAN cable to to your computer. So LAN cable where you will connect it, there will be an RJ45 jack. To that RJ45 jack you will connect it. What is that RJ45 jack actually? That is the plug to your network interface card, which is there in your computer. Like that, you are supposed to have 3 network interface cards to be attached to this computer. One is for the external interface, one is for internal, and one is for the DMZ. Multiple DMZ or firewall configurations. Server farm, that is a group of servers connected to their own subnet work together to receive requests with the help of load balancing software. Load balancing software prioritize and schedules the requests and distributes them to the servers. So here mainly, whenever multiple DMZs or firewalls are configured, so huge traffic, whenever there is huge traffic, that is terabytes or more than terabytes of the traffic is coming, then one host cannot balance. When host is not sufficient to hold the traffic. So that is the reason multiple hosts, dual hosts, will be placed in multiple places of the network, so that the workload will be equally balanced. That is what is called multiple DMZ or firewall configuration. The summary of that is. So here load balancing software will be used for prioritizing and scheduling the requests and distribute them to the servers. Clusters of servers in DMZ help protect the internal network from becoming overloaded. Each server farm or DMZ can be protected with its own firewall or packet filter. It will be like this. In the previous slides, we have seen very simple configuration. Now it is a little bit more complex configuration. You look at internet or untrusted network. So whatever the traffic is coming from the public domain is coming to the first screening router, and here also a screening router, and here also screening router, and here service subnet, email server and web server. This is one DMZ, and business partner access subnet. This is one DMZ, and where we will be having these directory servers, file servers, and all. And service subnet where we will be having another kind of DMZ. Okay, so again from this outer firewall is attached, and from this business partner and access subnet one outer firewall is attached. Subnet services one outer firewall is attached, and again from all these firewalls a connection is going to the again screening router handling traffic into and out of the internal network and management subnet, and from there the internal network is connected, and from the internal network of one subset to the internal network of another subset, one more firewall is attached, so that no malicious traffic will go from one subnet to the another subnet or from the outside to the internal subnets. So this is the way a complex structure has been designed. This is also said to be multiple DMZs protection are protected by multiple firewalls. That means based upon the higher level of security that you require, you need to design the complexity. You need to choose the complexity of designing this firewall or the placement of the firewall. It is just like making a layered security. If one fails somewhere, it will be caught, and if one fails somewhere, it will be caught, like that. So the traffic you are not giving any gap or any loophole for the malicious users or malicious or attackers to pass through the the organizational network. Thereby, you are making the entire system secure. This is what the ultimate goal of designing the firewalls or configuring the firewalls in the computer network. Multiple firewall configurations. Many organizations find they need more than one firewall. So one firewall is not a ultimate thing that will give you entire security. Obviously, the organizations require multiple firewalls. Must be configured identically and use the same software. So whatever the multiple firewalls that you use, it may be of same type, or maybe of maximum it will be of same type. Whenever you use that, all softwares must be of same version, same patched thing, and equally updated and all. Otherwise, what will happen if any mistake or if any mismatch is there in the configuration, then automatically it will be a loophole for the security. One firewall controls traffic between DMZ and internet. Second firewall will control the traffic between the protected network and DMZ. Can also serve as a failover firewall. That means if one firewall fails to protect it, then another will try to protect it. Advantage can control whether traffic goes into the three networks you are dealing with. So you look at here. This is one more architecture. Here from internet you are getting the traffic, which is an untrusted traffic. First router is there, which is going to screen this traffic. Then go to the firewall. This is called external interfaces, and these external interfaces again, this firewall may be directly going to the router which is handling, and this firewall may be connected to a switch, and from there one subnet may be there and another subnet may be there, where we can say this service subnet, and this service subnet is going to be DMZ1 and DMZ2, and in this DMZ publicly accessible resources will be placed, and here also the publicly accessible resources are placed. Okay, and the traffic which is going from the other corner, and this screening router will decide which traffic has to pass through which firewall, whether the first firewall or second firewall. And if the request is coming to the internal network, then it will pass through this firewall. Otherwise, if it is traffic is to the public network, then it will pass through this firewall. Okay, the second firewall. So if any internal node want to communicate with the DMZ public services, then this particular router will communicate with the firewall, second firewall, and they may utilize the public services. So this is the way two firewalls used for load balancing. That means if I place one firewall itself, then one firewall has to take care of the policies such as whether to go into the internal network or to the public network. Instead, if you place a screening router at the beginning, and if you make a policy that HTTP or SMTP, FTP related traffic has to pass through this, and any other request which is related to the internal network may pass through this first firewall. So this is the arrangement you can make it. Multiple firewall configurations in which the protecting branch offices from multiple firewalls. Multiple firewalls can be implement a single security policy. Main office has a centralized firewall, directs traffic from branch offices and their firewalls, develops security policy and deploys it through firewall using a security workstation. Each branch office has its own firewall. Security policy from main office is copied to every firewall. This is the way one more architecture can be developed. So here the traffic coming from the untrusted network, and here this is the firewall and screening router and another second firewall. So this screening router will decide which traffic has to pass through which firewall, and this screening router is attached with the security workstation. Here this is the centralized security workstation. Here it is, you are going to monitor what type of traffic is diverted to what type of to which DMZ, and these DMZs may be presented in different localities of the company. So from this firewall again a screening router will be placed here. From there again firewall which is connected to the main office, and from this screening router to another screening router which is connected with the second firewall at the entry level, and from this to branch office. So from the security workstation itself, we can come to know what is the activity happening, what is the activity or what is the traffic going to the main office, and what is the traffic going to the branch office from just by sitting at the security workstation itself. So from the security workstation itself, you are going to protect multiple branches, branch office, and here also another branch office, and main office DMZ and main office thing. So multiple firewalls protecting the branch offices. Next one is reverse firewalls. The reverse firewall is nothing but it monitors the outgoing connections. Majorly, the firewalls will observe the incoming connection. The reverse firewalls are one which will monitor the outgoing connection. Instead of trying to block what's coming in, they will go for monitoring the outgoing connections, that is from the internal network to the public network. Helps monitoring outgoing connections, attempts that originates from internal users, filters out unauthorized attempts. Companies concerned with how its employees use the web and other internet services can use the reverse firewall to log connections, block sites that are accessed repeatedly. That means you look at in our university also, if you try to access a particular site which is blocked but not filtered in the firewall repeatedly, after some time you will find that that particular website is blocked. Okay, you might have experienced it or not. I don't know, but in general it will be happen like that because our university servers are protected with the reverse firewalls also. That means from internal systems, what are the websites that are frequently accessed and which are supposed to be which are against the security policies of the university. Those will be banned. Those will be blocked within 1 or 2 days. So because every day auditing will be happened by the security team there, and they will look after the what are the how many number of hits that has happened to a particular website over a period of time. They will analyze them, and anyhow the analyzing software and all everything is available. Just by looking at analysis, they can come to know that which website has been frequently accessed by the internal employees or maybe internal students or maybe anyone. So they can directly block such kind of things, or especially they will block the sites that are accessed repeatedly, which are not supposed to access. So advantages and disadvantages of firewall configuration. This table will summarize the advantages and disadvantages. In case of screening router, simple screening router is very simple, inexpensive, good for home applications if a stateful packet filter is used. The disadvantage is provides only minimal protection. Viruses, Trojan programs, and some malformed packets might get through this particular screening router. Dual home host, simple, economical, can provide effective protection if configured correctly. Disadvantage is provides a single point of entry and sometimes maybe a fault. The firewall depends entirely on the host computer. When in case of screened host, previously screened router, now it is screened host. Provides a two-layer of protection. Home and small business networks can take advantage of this screened host. But this one also will provide the single point of entry. The firewall depends upon the host computer and the router protecting it. Screened subnet DMZ. This is a little more complex compared to the previous one. Protects public services or public servers by isolating them from the internal network. In the previous case, there is no isolation of the internal network and DMZ. But here, in the screened subnet DMZ, the isolation of the internal network, isolation of the public servers from the internet has happened. Servers in the DMZ are highly vulnerable and need to be hardened. Multiple DMZs are firewalls. This is a little bit more complex configuration than the previous configurations. Provide layer of protection for a business network, and it is very expensive. Single DMZ, two firewalls, balance traffic load in the high traffic situation, but still it is expensive. Branch offices or multiple firewalls provide protection for all offices in a corporate network as well as a central administration. Firewall must be purchased, installed, and configured at each office location. The reverse firewall monitor attacks from the inside the network, enable the organization to monitor user activity. But what will happen is it can slow the user access to the external network or other parts of the internal network. Among all these things, first two, three, there is screening router, dual home host, and screened host are simple to configure, and the devices also you can purchase for the lower cost. But as you look at here, screened subnet DMZ, multiple DMZ, and single DMZ are very costly. And setting up of the things and configurations is also require a lot of time and expertise. So these are the advantages and disadvantages of the firewall configuration. Now let us examine the proxy servers, because firewalls will also be placed before proxy or after proxy. So proxy servers, softwares that forward the packet to and from the network being protected, caches web pages to speed up the network performance. This is what the advantage of the proxy server. Especially the proxy servers are used to not to make to not to pose huge traffic onto the real web servers. So if anything to be accessed, if anything to be answered, answered frequently, or if any frequent accessing is there from the users, that can be directly accessed via proxy servers instead of going to the web server. Like for example, cache pages, or maybe any cookie related information, or verification of the passwords, these kind of things, internal passwords, that can be directly handled by the proxy server instead of sending the load on the main server. It is just like for example, if you look at a New Delhi railway station, okay, in New Delhi railway station, the number of trains to stop at the New Delhi railway station, or the number of trains destined to New Delhi railway station are very less compared to the trains that are coming into the Delhi area. Because to not to have load on the New Delhi railway station, there are some railway stations which are nearby, such as Old Delhi, or maybe Hazrat Nizamuddin, or maybe Anand Vihar, or this kind of things. So what is happening is instead of going entirely all the trains into the New Delhi railway station, they will stop at the before station itself to not to have more load on that. In the same way, just to recall this picture in your mind, to whenever this proxy server is going to be proxy server situation come into the picture. Instead of going the traffic to the main server, the proxy servers are placed before that, who will answer on behalf of the web servers. So this is the way the proxy servers are configured. Usually, the goal of proxy servers are like this: speed of the network communication. Information is retrieved from proxy cache instead of the internet. If the information has not changed at all, then it is very easy. No need to access the same information again and again on the real web servers. Instead, proxy servers will access. Goal of modern proxy servers are like this: provide security at the application layer, shields host on the internal network, and control websites users are allowed to access. So provide security at the application layer means it will provide the HTTP and HTTPS security, and shield hosts on the internal network. That means public network, public users will not come to know what is the internal network's configuration. So that is in this way the proxy servers will help us to not to know the internal network configuration. And same time, control websites users are allowed to access. So which websites to be accessed by the users, which are blocked, that can be set in the proxy servers. So here is the public traffic, the traffic coming from the internet, and there is a router, and to this router the proxy server is attached. Okay, this proxy server is attached. In this proxy server, you will be having cache. So, so this router is connected to this remote computer request web page from the web server. Then it will be handled at the router level. Then it will go to the proxy server. The proxy server cache will be there. The request will be checked in the cache. So proxy server receives the request and checks the disk cache. So then the proxy server will respond. Proxy server returns if the file is available. If it is not available, then it will go to the web server, which is available in the DMZ. Okay, it is available in the DMZ. So file not found, cached by the proxy, are taken from the web server. Okay, then proxy server will recreate the response which is received from the web server and will send to the requester. And if the request is to access the local area network, then LAN gateway will be connected. From the LAN gateway means a server which is placed before the LAN. Okay. From there again the local area network will be connected. Okay. So this is the way the proxy server will help us in caching the web pages and other files that to be accessed from the outside of the organization. How proxy servers work? Proxy server goal is like this: prevent a direct connection between the external computer and an internal computer. Proxy servers work at the application layer, opens the packet and examine the data, decides to which application it should forward the packet, reconstruct the packet and forward it, replace the original header with the new header containing the proxy's own IP address. The proxy server replaces the source IP address and their own addresses. So the traffic which is coming from the internet, which is handled by the proxy server. So web page request by the source IP as 10.0.20.28. Destination IP is 188.192.101.5. This is going to the public IP address. Then this web page request will come here, and then proxy receives the request. Then request received as the proxy server's IP address. So instead of 10.0.20.8, what it will do is it will cover up this local address with its own address 211.24.120.5 and will go and connect with the public web server where this 188.192.101.5 is there, and it will connect. Then the page will be returned to this 211.24.120.5, which is a proxy server. Then the proxy server will recreate the response with its own IP address, and finally the proxy receives the web pages, and these web pages will be sent to the web page returned to the source IP 10.0.20.11 where it was accessed and where it was initiated, and destination IP as the 10.0.20.28 from where it was originated and will received by the other computers. So that means proxy server is going to add its own header. Okay, that you are supposed to remember. Proxy servers will add its own header whenever any other request comes from any other systems. So that the requester system's IP address will not be used for forwarding the request. Instead, they will use their own IP header in which the proxy server's IP address is available. So many of the universities and organizations will use this proxy server, especially to filter the traffic, and they will ask their employees to use the proxy server address while accessing the internet. If you want to experience the proxy server, you may use the very famous open source proxy server used in the Linux operating system called Squid, SQID, Squid proxy server. So Squid proxy server is a very famous proxy server, widely used by many organizations wherever they use the Linux as the server operating system in their servers. So just now we have seen how the proxy servers will work. Proxy servers receive the traffic before it goes to the internet. Client programs are configured to connect the proxy server instead of the internet. So the web browsers, email applications, all these things will go to the proxy server only. So and remember, wherever this proxy server is used, and if any organization is asking you to use the proxy server to access the internet, that means whatever you browse, everything will be recorded in the local proxy server. It won't go to the internet. Okay, it will be recorded at your proxy server level itself. Then it is very easy for the security engineer to sit at the evening and can analyze what are the sites and what are the other things that you have browsed, okay, in the proxy server. Because the proxy servers will record the log. Okay, so how you will set the proxy settings? You can go to the internet settings. There you can go to in the browser. You can go to the internet settings. There you can choose the proxy settings in which you will set the proxy address. So in locally I may use a server system in which I may install a Squid proxy server. The system's IP address is 170.168.1.1 and the port is 8080. So I need to include this. So from there onwards, whatever I browse through that browser or to the system, that will first will go to the proxy address, and the rest of the operation that I have explained just now will be taken place. The proxy server's advantages and disadvantages: examines the contents of the packet and filters on contents. That is the advantage. Is the internal host IP address. So no one knows that is public users in the public domain. No one knows you that what is the internal IP address, because it will be mapped with the host, the proxy address only. Caches web pages and faster access. Provides a single point of login. Where in case of disadvantages are like this: security can be weak depending upon the configuration. Can slow down the network access because everything has to pass through this. Might require configuration of client program to use the proxy server. Provides a single point of failure. If the proxy server fails, that's all fails. Okay, again you need to resubstitute, or you need to configure another computer with the same IP address, and you need to reconfigure all the proxy settings. Then you need to ask the employees to access. Choosing a proxy server. Different proxy servers perform different functions. Freeware proxy servers, often described as content filters. Most do not have features of business applications. Example, Squid Linux proxy. So if you are running a small enterprise, then you are encouraged to use this Squid proxy server. Commercial proxy servers offer web page caching, source and destination IP addresses translation, content filtering, and network address translation. Example, Microsoft Forefront Threat Management Gateway. This is a proxy server that you can use with the Microsoft servers. That is Windows 2008 server or Windows 2016 server. Proxy servers that can include firewall functions also, having an all-in-one program, specified installation, product updating, and management. But the disadvantage is a single point of failure may result into the huge disaster. Try to use several softwares and hardware products to protect your network. Filtering content, especially the proxy servers, can open packets and examine the data. That means whatever the packet you send from the network, that is from within the network to the outside, internal to the outside network, or which are coming from the outside to the internal network, every packet will be opened by the proxy server. Please remember. Proxy servers can filter out content that would otherwise appear in the user's web browser, block websites that with content your user should not be viewing, should not be in a position to view, drop executable programs like Java applets, Java X controls. Okay, those things will be dropped. Security software does not operate on its own because this is related to the proxy server. Now we'll see the other setting in the security configuration. It's called Bastion computers, which is especially like hardware-based firewalls. So security software does not operate on its own, installed on computer that needs to be as secure as possible. So that is the reason we'll go for Bastion host. Computer that sits on the network perimeter has been specifically protected through operating system patches, authentication, and encryption. Previously, what are the firewall settings and things what we have seen are the software based. Here, Bastion host is a computer. You are keeping a dedicated computer which will take care of both hardware and software related things. So this is what is called Bastion host. The general requirement like this: steps in creating a Bastion host. Select a mission with a sufficient memory and processing speed, because it has to withstand to the traffic that is coming to the internal network and also going out of the from the internal network. Choose and install operating system and any patches or updates. Determine whether Bastion host will fit in the network configuration or not. Install services you want to provide. Remote services and accounts that are not needed to be removed. remove the services and accounts that are not needed from the bastion network, bastion host. Okay, back up the system and all data on it. Conduct a security audit, connect the system to the network. So these are the requirements, these are the steps you are supposed to do before creating the bastion host. Selecting the bastion machine host machine is like this. Select a familiar hardware and software, not necessarily a latest one. You can take a old configuration system also to make it as a bastion host. But one thing is, you need to check whether the network interface card that is available with that computer, old computer, can support the huge traffic or not. That is important to check. And also should have at least a dual core or a core to duo processor for processing the traffic. So ideal situation is one bastion host for each service you want to provide. So for FTP service, use one bastion host, and another for the web service, one bastion host. SMTP server, one bastion host. Choose an operating system to work on that. Pick a version that's secure and reliable. Checks operating system website for patches and updates, and particularly update the bastion machines. And always it is recommended to use the Linux operating system for the bastion host, because Windows require Windows host can be easily captured or easily tampered. Now Windows 10 is there, which is more secure, but the Windows 10 is you are supposed to purchase it, and which require again costly effort. So it is recommended to use the Linux operating system with long-term support, where regular security patches and updates are readily available. Memory and process speed. This is very important, because what are the packet which is coming into the bastion host must be first, a buffer will be created and we will load it into the memory first, then the processing will take place. So memory is always an important when operating on a server. So bastion host must provide only a single service, does not need gigabytes of RAM. So if you have a sufficiently large RAM, maybe of 2 GB or 3 GB, it is sufficient for the 100 Mbps speed or this kind of speed. So match processing power to server load, match processing power to server load. You might have to upgrade or add a processor if needed. Location on the network, typically located outside of the internal network, combined with the packet filtering devices. Multiple bastion hosts are set up in the DMZ also. So this is the traffic coming from the internet, and here packet filtering router, firewall or bastion host. So you are going to place a computer here, which will be acting as the bastion host. So in which you are going to you are going to configure the firewall rules, and this bastion host will decide whether the traffic is for the FTP or a web server or something. Then from there, packet filtering server will be taken, will be enabled. So in this packet filtering server, it will decide whether it is going to the internal network or FTP network or any other network. So bastion hosts are often combined with the packet filter routers, and this is a network configuration when it is connected with the packet filter routers. If the bastion hosts are connected with the DMZ, then this is the DMZ, and here packet filter router, and you may configure a bastion host here along with the packet filter router, and here also packet filter router, and along with this you may configure a bastion host. So that bastion host will take care of the traffic which is going to the DMZ, and that is from the public network to the DMZ and DMZ to the internal network. Hardening the bastion host, the simpler your bastion host is, the easier is to secure. So selecting services to provide, close unnecessary ports, don't open on all other ports, only the ports that are required and to access. For example, FTP is there. What are the ports required for FTP to access? Only FTP related services to be allowed. SMTP, for example, 25 is the port number. Only if you are running bastion host for this SMTP filtering, then only enable 25. All other ports must be closed. Like that you are supposed to do. Disable unnecessary user accounts and services. So don't create a duplicate users or temporary users or something. Only one user must be provided with which you can enter or close the system. Reduce chance of being attacked. Okay, that is what the intention of the closing of unnecessary accounts. Next is do not disable routing of or IP forwarding services. Do not remove dependency services. System needs them to function correctly. Stop services on one at a time and check the effect of the system. If the system is not disturbed with the stopping of the services, then the system that services may be stopped. But if a system is giving you any trouble after stopping the services, then the services must be needed for running of the bastion host. This is the way you will use it. Next one is using honeypots. Honeypots are you may recall the concept of honey trap. Okay, so honeypots are like that. So honeypots are placed in the network to attract the traffic. Okay, to attract the traffic. So attackers will feel that honeypots are the original servers and will try to perform the attack. Thereby, honeypots will record the log of what type of attacks are being performed. Then that logs will be analyzed by the security engineer to know, okay, this is the cause of, or this is the weakness of the attacker, and with which the security engineers will design the security policies to more strengthen their network. So that is what the honeypots means. So whenever honeypots are there, you recall that honey trap kind of thing. In recently, we have seen the newspapers and all. Okay, an officer was honey trapped and got the secret information and all. Okay, just like that. So honeypot, computer placed on the network perimeter, attracts attackers away from critical server. Appears as real, but those are not real systems. They are especially there for trapping the attackers attention and to know the attacker's information. Okay, appears real, can be located between the bastion host and the internal networks. Network security experts are divided about honeypots, whether to use the honeypots or not and all. Laws on the use of honeypots are configured confusing at best. So whether to use the honeypots or not. So there are some country to country the laws are there, but at present in our India there are no specific laws for the using of honeypots and all. Okay. Another goal of honeypots is logging. Logs are used to learn about attackers technique. So a honeypot in the DMZ is like this. So here in traffic from the internet, here is the bastion host. So in the bastion host, attaching with the bastion host, a honeypot server was placed. So the one who are accessing from the who are accessing the public resources from the outside of the network will feel that this honeypot server is the one which is responding the request to the web, mail, and FTP. Okay, so this is the way the honeypot will be placed in the organizational network. Disabling the user accounts. The default accounts are created during the operating system installation. Some of these accounts have blank passwords. So disable all such user information. Only keep the administrator account. And always try to make the backups and auditing. So in order to do backups, essential steps are like taking of the backups every weekly or daily or something. Detailed record keeping must be there. Auditing must be there. In which what are the things to be backed up? Logging of the files. That is copy log files to one computer to another computer in your network. Should go through the firewall to screen for the viruses and other vulnerabilities. Audit all failed and success attempts to log on the bastion host, and any attempt to access or change the files are to be should also be recorded. And next one is network address translation. The network address translation is especially used for converting the public address to the private address. So originally designed to help the conversion of the public IP address, because for any organization from the internet service provider, only one public IP address will come. Maybe few one or two public IP addresses depending upon the service they offer. So that public address is in general will be used for getting the internet. But however, within an organization you may have so many computers. So how this particular internet can be supplied to all these computers? So that is the translation will be done with the help of network address translation. Receives requests as its own IP address and forward them to the correct IP addresses. Allow the administrators to assign private IP address range in the internal network. So what the NAT devices will do is NAT devices is assigned a public IP address. Primarily, that address will be translated to the private IP addresses. That is called one-to-one NAT or many-to-one NAT will be the two categories under the NAT. So one-to-one NAT will be like this: process of mapping one internal IP address to one external IP address. That is what the one-to-one mapping. Internal client sends a packet destinated for external host to its default gateway on the NAT device. NAT device repackages the packet so its public interface appears to be the source and sends to the external host. External host respond to the NAT device and NAT device repackages the response and sends it back to the internal host. So this is called network address translation. So here is the example one-to-one NAT. So here from the internet, one public IP address we are going to get here. So first, the internal computer, which is on the 172 series, is want to communicate with the 206.188.95, which is available in the internet. Then the request will go like this to the NAT device. The NAT device will give the translation, and this particular translation will be the IP address of the NAT device. That is after translating. Then it will be added as a source as 197.205.16.211, which is the NAT device conversion. And the destination is to 206.188, which was requested by the 172 series internal, that is private IP address in the internal network. And this request will go to the internet and will go to the corresponding server. Whatever the response received by this from the server, that is which is on the internet, will be again come back to here. That is as the 206.188.95 as the source and destination as the NAT device. And this NAT device IP address will be mapped to the corresponding internal computer which requested for the service. That is 172.16.25.12. So that is the response will be given to the corresponding computer. So this is the one-to-one NAT. That means one private address to the one public address it will convert. While coming to the many-one NAT, uses the TCP and UDP port addresses to distinguish between the internal clients, allow many internal clients to use the same single public NAT interface simultaneously. Disadvantages is you can hide only so many clients behind a single IP address. Performance sometimes degrade as the number of systems increase. Do not work with some type of virtual private networks. So use only the single public IP address. Cannot provide other services such as web servers. So here is an example which is indicating the many-to-one map. So any number of any device that is so if you look at this diagram, in this the computer 1, 2, 3 all can request to the service at a time. So this NAT device, what it will do is all the multiple requests coming from the internal network will be processed at once. That is, which is called many internal IP address requests will be processed at once as a single public IP address. And this NAT device, what it will do is whenever it receives the response, the corresponding responses will be sent to the corresponding ports depending upon the port ID or port number that they mention. For example, here 170.16.25.12 on port 2250 it was mentioned. It was made a request to the 206.188.95 on the port 80. So it will remember the port on which this internal computer has requested for the service. So whenever the response has been received, then the response will be dispatched to the corresponding computer on the specific port it was mentioned at the time of request. So this is the way one-to-many NAT will be performed. To summarize this chapter, firewall design includes planning location for firewall placement. You can use multiple firewalls when you need multiple DMZs or to provide load balancing. Proxy servers catch web pages to speed up network performance. Today can perform firewall and NAT tasks as well as in the case of proxy servers. So proxy servers will do the both firewall and NATing tasks. Bastion hosts are computers that are accessible to the untrusted clients, such as web servers, email servers, and proxy servers. Network address translation is used to protect the internal clients from the direct access by the untrusted and external hosts. Decreases the need for public IP addresses in case of network address translation. Many of the same commands used to configure the Cisco routers and switches are also applicable on the Cisco firewalls. This is the end of the chapter. In this chapter, we have seen the firewall configuration and management with respect to the types of firewall configurations and based upon the security that what we require, the classification of the placement of the firewalls, along with the screening routers and the DMZ, and along with the Bastion host and honeypots. At the same time, finally, the network address translation, and along with the proxy servers that can be included in the network architecture to strengthen the security of the entire organizational network.